Hi, this is the fourth module of the Lean series, Module 1D. We'll be reviewing Kanban and workflow. We'll also do a wrap-up, which will be at the end briefly, and then we'll discuss the Lean worksheet assignment. So Kanban, we're going to review this one first. Kanban is a signal that we're going to learn about in the next few slides. You can see that, again, this is part of the building blocks of Lean. So where does Kanban come from? It's from the Japanese. This is where we see this as a signal in our process. It's also been referred to as just-in-time or JIT manufacturing. So basically what we're looking for is we're looking for a signal from a process or an operation that's going to tell us when and what to do. Okay, so we're not going to work unless we've gotten a signal that's going to ask us to produce some sort of product or report or requisition, whatever our process is going to need. That's what the signal is going to tell us to do. Some of the issues that we have with push systems is we have too much inventory. I'll give you an example. I worked in a manufacturing environment where one operation was doing some photo imaging. The next operation was a plating department. And because the imaging department didn't have a lot of problems and had a lot of capacity, it would outproduce the plating department. So if the photo imaging department is producing, say, 500 panels a day, and the plating department is only producing 400 panels a day, then every day there becomes a surplus or a backlog of an additional 100 panels each day going through the plating department. Now this may go on and on for the course of the week, and here comes Friday afternoon, and certainly we don't need any more work coming out of the photo print department. So the plating department, that department may have to work on a Saturday, and maybe they come in and they get about 200 panels out. But we've already passed them an extra 100 panels every day that week. So we've got 300 more in the backlog to start the following week. And here comes 100 panels a day every day for another 5 days. They work the weekend. There's 200 more down from the backlog, but you can quickly see how the panel count and the backlog in the plating department will grow and grow and grow. What do we have to do? We've got to throttle back that photo imaging department somehow. Unfortunately, what happens is because you have such a large backlog of panels, the order of processing starts to become jeopardized. So you have a hot job that comes out of the photo imaging department that is not sitting in line. It's jumping over all of those other panels that are sitting there. So some of the product that may be in the plating department's backlog may actually be sitting there for more than a week's time, maybe several weeks or even a month, because of the order of processing. So what do we have to do? We need to look at a few things. One is thinking about how do we increase the production through our plating department, but then we also have to do, in the meantime, we have to consider throttling back and not just pushing work through our photo print department. What we really need to do is we need to consider that we have to put some sort of limitations or signal on that so that they're only going to produce at a level that the plating department is able to produce. So what we'll do is we'll issue some sort of Kanban, or we'll put a Kanban system in place to take care of that. One last comment that I wanted to make before we left the last slide is the example I was talking about. If we had a large amount of product sitting in front of the plating department, some of that product may be sitting for weeks and weeks of time with film on the product. And this actually created some problems in the plating area where we had some film that started to lift off the panels, and in other cases we had film that, because it had stayed on panels too long, when we went to remove it later on in the plating process during one of the stripping operations, we actually had problems removing the film. So with large backlogs, we generally have delayed processing, and with that often come quality problems. So Kanban systems, pull systems, are actually going to help us to reduce the amount of backlogs and help us with that throughput so we don't have products sitting for long periods of time. I'll talk about material handling in just a couple slides as well. So we have these two departments, and basically how a push system would work is photo imaging would just simply process everything that they had as quickly as they could through the area. And often we see this as almost a game that manufacturing managers will play. Just keep pushing the product to the next department, and somehow we'll see what we can do to get the product through the next department. And generally, if you have a department such as plating that has limitations and is more of your bottleneck, again, you're going to have quality problems, and then you're going to also have a large amount of work in front of these people, and that can get a little overwhelming at times. So if they're tempted to move faster, take shortcuts, there's even additional quality issues that may come from that. So we don't want to put people in situations where they're making decisions that may jeopardize the product quality. So here's our pull system example. The status at either photo imaging or plating, they either have work and they're full, or they're empty without work. Okay, so those are the two statuses that they have. When they are both full, we really don't want the photo imaging process to push any more work to the plating department because they've already have enough to work on. They're full, they're going to work down their backlog. If the photo imaging department is empty and the plating department is full, they've got a full backlog, we're still going to ask them not to work. One, because photo imaging doesn't have anything to work on, and two, the plating department is full and they certainly have stuff to pull from their backlog. So in this particular case, we're not going to work for two reasons. One, again, we don't have stuff to work on. The other one is we're full on the other side. Example number 3, photo imaging, they can't work. Again, they don't have any product, they're empty, their backlog's empty. And the plating process, they're actually empty. So they want work and they want the imaging department to work, but the imaging department can't work because it doesn't have any product. So again, we're in a stop mode. The only time that we're going to ask this photo imaging department to work is when they have product to work on and the plating department needs product. Now in this particular example, again, we've got 4 different situations here. The imaging department is only going to work at that 4th level when the plating department needs work and they have stuff in the photo imaging department to work on. What I will tell you is that we're not going to wait for the plating department to get completely empty, but we are going to let their backlog drop to a certain level. Maybe we tell the photo imaging department that you're only going to work if the backlog is down to 200 panels, and you're going to stop working if it's above 600 panels. And the only exception to that would be you would allow the photo imaging department to process any, say, rework or premium time orders. So there can be some other rules surrounding the pull system. So using the examples that we're talking about, what I'd like to do is go through these and see if you can tell me whether these are pull or push systems. So a soda vending machine, do you think this is a push or do you think it's a pull? The vending machine is only going to dispense a soda when I select it. It's only going to dispense it if there's soda available. So it's not going to dispense if it doesn't have the particular type that I want, and it's certainly not going to dispense it until I ask for it. So that's a pull system. Emergency department waiting room. If you think about it, they really don't know who's coming into that department, right? People could walk in at any particular time. There could be an accident. We've seen TV shows or heard of emergencies where they don't have anything in an emergency room, and then all of a sudden they've got 15, 20 ambulances pushing their way through the door. So an emergency department waiting room, they're that's a push situation. Now, as they pull them into the actual emergency department, they're only going to pull them in if there's a room available and there's a person that needs to come into that room. So pulling them into the emergency department, that would be a pull system. Again, we're not asking people to rush through the waiting room into the emergency department. We're only going to do that as an on need basis. Supermarket goods on a shelf. If you think about this, this is actually a classic Kanban system. Supermarkets only put out the amount of product that they believe is going to sell. And they're not going to have 3 rows of just ketchups. They're only going to have a certain amount of room on a shelf devoted to ketchups, different size ketchups. And through history of consumer purchases, they're going to understand what ketchups sell and what volumes are sold, and they're going to stock their shelves accordingly. So supermarket is the classic Kanban system, and again, they're going to replenish whether it's ketchup, mustards, anything, loaves of bread, anything on the shelf as the items are pulled away. So our stock people are going to, again, replenish based on a pull system. Exiting the movie theater. If you've seen a movie recently, you absolutely know that this is a push system, right? There is no orderly fashion to exit a movie theater. It's basically every row. You've got people at the end of your row, standing up, waiting to exit out, and obviously it's a push situation, and there's backlogs at every single one of those rows. Most people that don't want to fight the rush, they simply sit in their seats for another 10 minutes until the movie exits, and then they're on their way. Runway at O'Hare during peak periods. I would say during peak periods and any periods, this has got to be a pull system. If it was push, we'd have planes landing whenever they wanted to, and we would have an absolute chaotic situation. So they're only going to allow a plane to land when, one, there's a plane available to land, and two, when there's an available runway. And obviously there's times associated where they're not going to land planes every 10 seconds, but amazingly they do land planes at very close to each other. So free runway, available runway, and available plane, that's when they'll land. If there's 2 available planes, obviously we're not going to land 2 on the same runway. Only 1 will be cleared. So that's a pull system. We're pulling them down into the free runway. Whopper without pickles. They're not just making these. They're not putting Whoppers on the shelves without pickles, and some with mustard, and some with ketchup. They're making these to order. So this is only done when it's pulled and requested. So this is an example of a pull system. Years ago, they would just manufacture and put burgers, tons of burgers on a shelf, and often they would put times on there too. And if it sat too long, they'd have to throw that out. So having pull systems would reduce the amount of food that was thrown away based on the fact that we made a lot of Whoppers without pickles that weren't sold, and they sat on our shelves for too long, and we had to get rid of them. So being able to make things to order is certainly going to prevent some defects, or in this particular case, some scrap from occurring. Now, within your particular organization, company, your department, what do you have? Do you have a pull system, or do you have a push system, or do you have some sort of combination? There's some levels of pull and push that are used in different areas. Think about what you could do with a pull system. Think about some of the benefits that you would have by implementing a pull system. So here's another example of what a Kanban system or a pull system could do for us. So we've got several pieces of inventory here, and we've got a very low stack on the 455. So what we're going to do here is we're actually, you can see on our green, yellow, and red Kanban rail, we have the 455 running, and we've got product coming out of our machine heading back and filling up our stock. So as that happens, we may start to use some of the 454 and possibly even some of the 456. When the 454 gets down to the trigger point, it's going to send a signal over to our Kanban rail that tells our operator the next job that you're going to be running is going to be the 454. It tells the operator he's going to possibly need to go get the blueprint, maybe some materials, whatever they need to do to set up that job. That's the signal. Okay, that's the next job that we're going to run. The 455 will be processed again to finish that order. The 454 signal that comes over may be a signal that says build 5 boxes, build 4 boxes. We don't know exactly. It's whatever the management team there has decided on. What I will tell you that if we start to use a couple more boxes of the 454, then we may put that into the red box, which may tell the operator to shut down and switch to that job right away. We don't know what the red box means on our Kanban rail. Only the people involved in the system, they should know what it means. It could mean a number of different things. It could mean, let's just say that we used up some of the 456 and we needed to replenish that one. Well, if that 456 turned out to be the next one and it filled up the red slot, then maybe by being in the red, that's a signal for us that we need to turn on a second machine. It may mean that needs to be jumped in front of any of the other processes that are, or any of the other product that's happening. That would all be defined as part of the Kanban system. So Kanban systems could be as simple as a pull one and then we're going to create one. So this would be indicated in a one-piece flow. So in the example of the Whopper without a pickle, we would simply maybe have one on the shelf, and then if that one went away, that would be my signal to replace that one. I'm not going to have any more than one of those up at a time. In the situation with the Whopper with a pickle, though, in most cases they were going to build it as the demand hits. There's another level that we talked about with the plating example in the photo imaging is pull till you hit a predetermined order amount or a replacement amount. So in some cases, if we said the backlog in the plating department got below 200, we knew that we were going to start to produce product in the photo imaging area. We're going to produce product until the plating department hits 600 panel backlog. And then we'll shut the photo imaging department off for a little while, or throttle it back, only producing the quick turn jobs or maybe out of position jobs, and again reducing the flow coming through that particular area. So there's different ways that we can use a Kanban. We can also use it to simply, we get to a certain level, and I've actually implemented this in some of our raw material areas where if my inventory gets down to a certain level, I'm going to order a predetermined amount of product. So we don't send requisitions out on a daily basis for 50 pieces, 50 pieces, 50 pieces, but perhaps once every week or two, we're replenishing, say, 400 or 500 pieces of material. So if we think about inventory levels as this water level, generally what we want to do is we want to have the lowest amount of inventory possible. But what will happen is as we reduce the level of inventory, we start to encounter problems. And some of these problems are long changeover times, maybe cross-training, quality issues, process capability. We don't have the flexibility. The example I used relative to the changeover of the lamination, the film laminator, perfect example of we didn't really want to have too low of a level because we wanted to be able to run 24-inch film and run it with lots of product until we ran out of film, and then just by necessity we would change over to a different size, and we would look around the room and say, okay, we've got a lot of 12-inch panels or 18-inch panels. What's the next size film we're going to put on? And we based it on the inventory level that we had, not necessarily which was the best job to work on. So we really love to have a lot of panels in our department because we had poor changeover. And these are things that I didn't even think about 25 years ago when I ran this particular department. It was just something that we lived with. So having a good understanding of throughput and some of the problems associated with higher inventory levels and all, and what I was doing to jeopardize on-time deliveries and all, kind of forced us to improve our processes. So before you lower your inventory, you've got to start looking at some of these other issues that are going to surface as that inventory level starts to fall. So the last thing that you want to do is drop your inventory and start hitting these problems. You want to anticipate some of them and reduce the effect of them. Are you going to eliminate absenteeism? No, but through cross training and maybe holding people accountable and bringing up the morale of your workforce so they don't want to take unneeded time off, you're going to reduce your absentee issue problem. You have it more planned. So plan your emergencies as best you can. Have contingency plans. Your downtime of your systems, as far as preventive maintenance and things like that'll keep your breakdowns to a minimum. Your long changeovers. Address all the problems as best you can prior to dropping your inventory level. Are you going to drop your inventory down to zero? Absolutely not. But you're going to be able to reduce it significantly based on the opportunities that you address. So think back now to our plating example, the theory of constraints, and we've probably heard about this before. Basically, any time that you have a constraint in your process, you can walk around any facility, and if you see piles of inventory, as I'd mentioned before, they've got one of two problems. They either have a capacity problem, they can't produce enough product, or they have some sort of quality problem that's slowing them down. Regardless of what that is, as you walk around the facility and you find that constraint or that bottleneck within your process, what you need to do is you need to help that constraint out as much as possible. So you may have one, you may have more than one, but every system has at least one weak link. All right. So what you're going to need to do is you need to determine what that link is, and you need to basically exploit that link. You need to help that link by possibly changing your batch sizes to accommodate that link. You need to make sure it's staffed properly. You need to do everything you can to help that link out, and then start to look at the things that they're doing within that process that could be enhanced. So the opportunities are going to most likely jump out. Make sure you're doing that with a team of people, and by improving that constraint and reducing the effects that has on your overall system, you're going to find out that you've got another weak link somewhere else. Okay, so as you take your weakest link and you strengthen that up, another link in your chain or in your process will become your constraint. Then you work on that one, and you keep doing that until you achieve the production and the throughput levels that you need to be successful. Next, we're going to talk about the layout and workflow. We talked about transportation and motion as two of our 8 different types of waste and inefficiencies. Both layout and flow module here will help us with both of those. So when we organize our cells or our departments into a more structured work area, what we're basically doing is we're combining operators with equipment and workstations and considering how the product actually moves from one area to another. So cellular manufacturing is meant to link these steps as closely as possible, and I'll even say as closely as practical, because we don't want people on top of each other. We want to have safe distances between them so they're not bumping into each other. But what we're actually trying to do is limit motion and transportation of product. This is not just transportation. Again, we want to think about motion too, because there may be some shared copying machines, there may be some shared files, things like that. As we're relaying out our work environment, we're going to relocate out things that, again, are not just going to enhance our transportation, but are also going to enhance our motion or action of our operators. Here's an example of a process that actually a building that has a kind of a crazy process. There's movement going all around, and I'll give you the just the beginning part of the process, which across the road is a kitting area. It comes in through the door, and if you can see in the towards the right, there's a staging area, stage 1. That's actually the first stop that it gets to. And I'm not sure if you can actually be able to see the cursor here, but it's right on the right middle is stage 1. The next part of this is about an inch or two to the left, where it goes into an incoming inspection area. That's step number 2. After it goes through the inspection area, it goes all the way over to the left and it gets baked. And then just to the right of the baking, which is on the far left, you have a screen printing, and then heating and a reflow oven. And then it goes all the way down towards the right into a wash area. So there's a lot of movements around. You can see there's a lot of back and forth. You can see a test area that's different from a final inspection area. We're back and forth to a washer. The shipping area is off to the far right, yet we have a final inspection area that was in the middle of the process, really close to the incoming inspection. So we don't have things next to each other. There's not very good communication, and this workflow is all over the place. So what can we do to do things a little bit better here? We actually want to spread our processes out in some aspects, but the things that are that work next to each other, and the operations that should be next to each other, we want to place next to each other. So we'll take some of the operations out, almost like a domino effect here. We're going to remove some, we're going to slide some others in place, and we're going to create a workflow that will allow us to have departments that pass product back and forth to each other, or pass product to each other next to each other. And what this is going to allow is not just for reduced transportation, but it's also going to enhance the communication between those departments. So if one department is a little slow on work, they may actually be able to help the process before them to get them work, and they'll be able to see what's happening there, because they're not going to be on the other side of the building. They're going to be literally right next to each other. So here's that same building, except this is how we've laid out the building a little differently, or I'll say a lot differently. The kitting area is still across the road. They drive it around and they stage it right on the bottom left. They stage it there. We have an incoming inspection, then we bake it, and we go into screening and the reflow oven areas. We've relocated the washer, and then we have an in-process inspection. All on the left side of the operation of the building here, and you can see it's a much cleaner flow. Towards the end of the process, I'm not going to go through the entire process, but if you look at the end of the process where it comes out of electrical test and then it goes to a final inspection area, the source inspection is right there. I think that was one of the few things that we actually didn't relocate, just above final inspection. And then it goes into our shipping department, or the OS, which is an outside service, which happens on occasion. So it's a much cleaner flow, and you can see here where if you had a choice, I'm going to go back one slide. If you had a choice to go from this or the other operation, you'd certainly want to have processes that looks very similar to this, and an organization that looked like this. One of the other benefits to this was our sales department, as they walk customers through the through this manufacturing floor. Which would you think they would have rather had as an organization to tour people through? a situation that looks like this or a situation that looks like a big pile of spaghetti. Spaghetti diagram actually comes from the fact that it looks like a big pile of spaghetti. So hopefully your after looks much more like this and less like that big pile of spaghetti that we saw earlier. So in our live lean day, we actually have a factory that we set up with individuals, and we have flow that is not exactly streamlined. Often this happens within different organizations because you add a process or a piece of equipment that you may not have anticipated, and because we don't have room in the department that we want to put it in, we wind up putting it next to the department or maybe down the hallway or on the other side of the building, and we figure we're only going to keep it there temporarily, and then 2 years later it's still there. So basically what we try to do is we try to anticipate for growth, and at the same time, every now and then we're going to need to take a step back and say, based on our flow, is there an opportunity to enhance the flow and help ourselves by redesigning our facility? So in this particular case, what I'd like you to do is take a look at your facility, and if there's a floor layout, do a little spaghetti diagram. Trace out where the product goes from one department to another, and see if there are some opportunities. It may not be an entire facility reorganization, but there may be some opportunities to redesign your facility and improve the flow, reduce transportation, reduce motion within your work environment. What I will tell you is that in addition to doing this across an organization, you can also do this within a department. So cells within a department take a single workstation, and you can do a spaghetti diagram using the same tool, the same layout, and just look at the work going through one particular department and see what the flow looks like there, and look for opportunities to reduce flow and motion within a single department. So you've now been exposed to a number of different lean tools and the 8 different wastes and inefficiencies that exist in all environments. We've used the acronym downtime. If you get a chance to watch the video of the waste walk, you'll see that we introduce you to a slightly different acronym. That acronym is hospital. That we use more in the medical field, but we also use that in some business environments with the thought that you need to get well. Both are good ways to recall the 8 different inefficiencies. Again, what we're trying to do is provide you with Lean 2020 vision so that you can see these 8 different wastes and inefficiencies, and then you can share these 8 different inefficiencies with people within your department. We want them to find them too. You, as you start to learn about the tools and become more of a tool expert, will then take their thoughts and ideas and turn them into solutions. You've been exposed to a lot of the tools within the Lean building block. You'll see more of them over the next couple days as we review the Six Sigma and the process control modules. If you have any questions, now's the time that you want to email them to us, and we'll get answers back to you as quickly as possible. And the next thing that we're going to ask you to do is complete the Lean worksheet. There's again 4 things that need to be completed: the 3 different worksheets and the test. So good luck with that. Here comes the explanation on the Lean worksheet. So there's 8 different types of waste, and we have them identified on this sheet. And so you've got 1 through 8. What we're going to ask you to do for each one of those is provide an example within your workplace. So the A portion is simply what is that waste or inefficiency. So whether you use the hospital acronym or the downtime acronym, whatever you decide, that's fine. If you use the hospital acronym, we're looking for 1A would be halting and or waiting, and the example would be something within your workplace would be placed in B. The C would be the solution tool, whether it's team building, brainstorming. Maybe you're going to implement a Kanban so that we don't wait for product. People know when to produce product, and we created a signal for them. Whatever the waste is. What's nice is as we ask this to be completed during the yellow belt trainings, and we do this with different organizations, we actually wind up with, say, 20 people in a class or 15 people in a class. If you have 15 people in a class and they've come up with 8 different um, uh, examples of waste and inefficiencies within their environments, it doesn't take too long to do the math. 8 times 15, that's 120. We now have 120 opportunities to go fix something within our work environment. So I'd encourage you to take this worksheet. You can make a copy of it. Provide the training, let your people see the 8 different inefficiencies, and then simply show them this worksheet and see what they can come up with within your work environment for the different inefficiencies. See if they can identify opportunities for each one of these, examples for each one of these. So we've got the waste walk video that you can show them. I think that's approximately 8 to 10 minutes long. And you've got this lean worksheet that you can be using to help you with passing this knowledge and information along. We look forward to seeing this. Once you've completed, you can send this off. People sometimes send one worksheet at a time. You can also send these to us individually. We generally reply back within 1 to 3 days on all submissions. Good luck.